Welcome to Accesso Lecture Series. This is a part of Hydrologic GIS Applications Lecture Series. And today we want to look at Thiessens, polygons, and areal average precipitation, which is one of very important hydrologic applications. So we will use QGIS to create and estimate Thiessens polygon areas. In this case, we will compute the potential area of influence relative to a precipitation gauge location. Then we'll calculate the weighted area precipitation. This method is expressed by the following formula, which is areal precipitation average or weighted area average is the summation product of weighted area of each polygon and the corresponding recorded precipitation divided by the total area of the watershed. The summation starts from the first gauge up to kth gauge. Could be 3, 4, 5, 6, depending on how many gauges you have. So in that equation, PF is the weighted area average precipitation. A sub K is the area of polygon corresponding to a gauge K. A sub T is the total area of the watershed. PK is the precipitation measured at gauge K, and K, of course, the number of precipitation gauge stations. Of course, what you want to be sure is that you have QGIS installed on your computer. If you don't have, you can visit their website to download the software, which is available for free. And as well, a part of this software should be Saga processing toolbox that we'll be using for today's analysis. Once you have launched your QGIS software, what you want to do next is to add two layers using add layer from the menu options. We will add a watershed polygon layer and the second one a points layer. Both of them are vector layers, preferably. And then here below we've shown how the map looks like once it's been loaded. We've added a third layer of streams just for the sake of showing the pattern of drainage within the watershed. Otherwise, this layer is not necessarily needed for this analysis. After loading the two layers, that is the points layer and the watershed layer, then you want to launch your Thiessens polygon from the processing toolbox. Typically, this is available from the Saga toolbox. If you cannot see it immediately, then you need to search for Thiessens polygons and it will show up. Once it shows up, then you can click on it to launch it. After this is launched, then a pop-up window will appear giving three options. The first option gives you the opportunity to load your points layer. Then the second is a window where you can enter your frame size. Typically the number there is 10, but you can put any number of your choice to suit your needs. The third selection there gives you an option to create a temporary polygons file. But if you want to save, you can give it a name, and therefore you create a permanent file that you can save in your drive. The map on this slide is the result of running the Thiessens Saga toolbox. You can see the Thiessens polygons that have got black boundaries. But at this point, the created layer needs further processing. To obtain the weighted areas, or to create the weighted areas corresponding to your gauge locations for your particular watershed, you can use the intersection calculator from the processing toolbox. If you cannot see it, then you can search for that toolbox called intersection, and it gives you three options to enter or to select your polygons, Thiessens polygons layer, then your watershed layer, and then to provide an output name for the layer that contains your weighted Thiessens polygons. For this particular exercise, the resulting weighted polygons, Thiessens polygons, is shown on this slide. Clicking on the points will show you the weighted area corresponding to each of those points. And then we'll also show some computations of the corresponding areas and their weights in the next slides. After you've created the Thiessens polygons, typically you would like to compute or calculate the areas of every Thiessens polygon. You can do this by adding a new field, give it a name like area 1, like we have done in this case. And then once you've done that, then you can calculate the individual areas based on geometry analysis. Once you've determined the areas of every polygon, you can calculate the weight of that polygon, which is given by the area of the polygon divided by the total area of the watershed. You can accomplish that by launching the calculator tool within the attribute table. That is the end of our presentation today. I hope you have enjoyed our short presentation, and if you have any questions, you can always ask us. And just make sure you give our video a like. Thank you. See you next time.